for the next input, we will have 3 speakers here on stage, and the input will be about the future of accessible mathematical and chart content in PDF. We have here with us Alireza Darvishy. He is a professor of computer science specialized in ICT accessibility at the Zurich University of Applied Science, called ZHAW. With him on stage is Felix Schmitt-Koopmann. He is a PhD student at the University of Zurich and research assistant at the ZHAW. And we also have Chuqiao on stage. She is research assistant at the ZHAW. Also here you have the possibility to ask questions in the chat. You can scan the QR code, or you can go directly into the app that we have for the University Future Festival today, and then we can discuss the questions directly on stage with our 3 speakers. So, welcome on stage, and I hand over to Professor Darvishy.
Hi everybody, thank you for coming here to our presentation. I'm happy to share this conversation with my PhD students. Since some weeks, also Chuqiao is a PhD student at the University of Zurich, as a short correction. Imagine you have a student, a blind student, who has to read mathematical or read scientific papers in PDFs. And these scientific papers have mathematical formulas and charts, scientific charts such as bar charts, line charts, or pie charts, or similar charts. Imagine, or you don't have to imagine, I'm here. I am a severely visually impaired scientist. Users like me, and also students with visual impairment, rely on special software called screen readers. Screen readers read aloud the content of a document. However, screen readers are not able to interpret contents such as mathematical formulas or scientific graphs without preparing the content appropriately. Preparing scientific content such as mathematical formula or graphs in a traditional way is time-consuming, expensive, and needs a special knowledge. Also imagine there are state-of-the-art tools such as Illuminate from Google that you can create automatically a podcast, as they say, with engaging conversations. Imagine that you want also to listen to such a podcast, which also has mathematical formulas and graphs. You go jogging and you want to listen to such a scientific content. To tackle these challenges, we have 2 research projects. One of them is SNF Bridge Discovery Project, and the other one, InnoSwiss Project. My 2 PhD students, Chuqiao and Felix, will give you insight into these 2 topics and also provide some background knowledge. We have also a 3rd project, which we start with ETH, a Swiss University project, and so dealing with using AI to create accessible teaching material. So I hand over to Felix.
Thank you very much. So I would like to start with 3 small examples about accessibility issues that you can often appear in scientific documents. So if you try to read such a paper, as you can see it here. And yeah, let's start with the first example.
Accessible PDFs.pdf accessible PDFs : applying artificial intelligence for automated remediation of STEM PDFs. Felix M. Schmitt-Koopmann Prof. Dr. Elaine M. Huang Prof. Dr. Alireza Darvishy University of Zurich, Department of University of Zurich, Department of Zurich University of Applied Science, Informatics and Zurich University.
So, as you could see, it is a little bit annoying because it cannot detect the columns directly. So it is reading it line by line. It's jumping from one column to the next one. This is happening quite often and make it very hard to understand it if you try to read it with a screen reader. So the next example I want to show you is about mathematical formulas.
Substantial cognitive load on the person with a visual impairment. Square root minus plus or minus 2 minus 4 equals left parent 1 right parent 2. For other formats such as websites, there are solutions with left quote math view.
So again here, it is reading some of the symbols, but the structure at all is not understandable. And also with the missing symbols, I would say it's for nobody understandable if you're only using the screen reader to understand this formula. So let's get to the last classic issue that occurs. It is with tables.
Example 1: example of the workwise of the math viewer at the example of equation 1. Table with 3 columns and 6 rows. Action. Output. Blank. Open math step into next right step into viewer. Square root minus plus or minus 2 minus 4 equals 2 equals square root minus plus or minus 2 minus 4 2 square root minus plus or minus 2 minus 4. Step into minus. Next right. Blank. Next right step out. Blank. Plus or minus.
So I stopped that. As you could see, it is recognizing the table completely wrongly. It says something about 3 columns, it's mixing up some rows and so on. So again, very difficult to understand that. So why is that happening? Why can the screen reader not read the PDF correctly? And to understand that, we have to get a little bit deeper how a screen reader works and how it is reading a PDF. So a screen reader is reading aloud the content on the screen. So on the screen, you usually have a 2-dimensional structure. As you could see here, it's you see the screen of this PDF, a little bit abstracted. However, a screen reader needs, in the end, a 1-dimensional output. So it has to linearize this content. So how is it doing it? So first of all, it needs the information like what are the text blocks. So in gray, they're shown. And again, together with the information, what is the logical order? What is the reading order of these? It can linearize that. To make it more simple to understand it and also give them some more semantic information and allow navigation, it also needs some semantic tags. So for example, this is a heading 1, this is a table, and so on, to make it really accessible for a screen reader. The problem now with a PDF is that we have none of this information in a PDF. In a PDF, you have a content stream. You can think about that as a list of operators. So a small example you can see there. So it's a text block. So we have this BT and ET is defining that's begin text, end text. And then we have 3 elements in it. We have the for definition. So with the for size, that's the first operator. Then we have the position of the text, and we have the text itself. So this is all the information you need to visualize it in the document, but there's none of this information that the screen reader needs. So what is the relation between the text content, what is the semantic meaning of it, and so on. And so to make it accessible, you have to add a struct tree to a PDF or structure tree. As you can see on the side. And this is the reconstruction of the document structure with so-called tags that are connected to each other. And in the end, so for example, you have the document that has as a child the paragraph tag, and then it is also referencing it to the part of the text content. So it's assigning these text operators that are part of this paragraph to it. So this is what you have to do to make a PDF accessible. There are many standards and so that are describing how you should do it. So if you want to, if you Google for accessible PDFs, you will probably see, these four things that are showing up, like regulations and so on. So we have, first of all, the PDF UA1 standard. That is the ISO standard for the PDF. It is based on PDF 1.7, and at the moment is the most used one. The Matterhorn protocol is comparable to the PDF UA1 standard. So in the end, it's only like a rewritten of this very technical ISO standard with more easy check questions. So you have all these check criteria in it, in the Matterhorn protocol, that you can use to check if your PDF is accessible. Last year, there was also published a new PDF standard that is based on PDF 2, and it allows to new tags, so there are no new semantic type of tags in it. And it also gets a little bit closer to the WCAG standard that is also often mentioned with PDF accessibility. However, WCAG standard was developed for web content, so it's not directly applicable for PDFs. However, the idea and everything is the same. So you also have these criteria that are overlapping with the PDF standard. Important to mention always is accessible PDFs are really not a perfect science. So it is usually you have multiple options, like these definitions are not so clear. So usually you can tag stuff differently. It is okay. And so in the end, the best is always you have to test it really with a screen reader if you want to ensure that's really accessible. Also with the checkers, it can give you some misleading interpretation of the accessibility of a PDF. So for example, the example of the beginning I showed you with the PDF, the Adobe checker will say this PDF is correctly accessible. So yeah. Now, as I shown at the beginning, with these mathematical formulas, we had the problem like it is not accessible at all, and so you have to add an alternative text for it. So for example, if you have this formula, you could write something like x1 and x2 equal negative b plus or minus the square root of b squared minus 4ac divided by d. So it looks good or not? The problem is, it is not. Because like really creating alternative text for mathematical formulas that is non-ambiguous at all is super difficult. And I cannot recommend it really to do it by yourself. It's even very difficult for experts to do that. And so the easiest thing is to use some converters. So for example, there exists the MathChex converter. You can also see there in a QR code. And it allows you to input like the LaTeX code of the formula, and you can add some settings and so on if you want to create you automatically a valid alternative text for mathematical formulas. So this is also one thing we integrated in a prototype we developed for making PDFs accessible. And this prototype is really split into these 8 distinct steps that show you in the end what I told you before, what we need to make a PDF accessible. So for example, first step is the region step. So there you are defining these text blockers, you are defining the different semantic tags. So you're defining which is in heading, which is in paragraph, and so on. In the second step, you're defining this logical order of the reading. So what is the logical order to read the document? Then very important is the heading structure always. in a PDF because it's also important on a website, because most screen reader users are using headings to navigate on a website or in the PDF and so on. So you should always check that the heading structure is correct. Then you have to define like the table structure. You have to redraw that so it is recognized correctly by the screen reader, not as in the example before. Then the same with the lists. You also have to recreate the list structure. You have to add the alternative text for figures. You have to add an alternative text for the formulas. As I show you before here, you can use an interactive editor, or you can type in directly your LaTeX code, and then it's using this mathchecks library to convert it into an alternative text. And in the last step, you can add some meta information about the PDF. So for the PDF standard, for the UA standard, it's also required that you are adding some of this information to it. And with that, I want to hand over to Chuqiao.
Thank you, Felix. And so now let us move our focus to digital graphs. And we all know that digital graphs are used everywhere across different domains, such as physics, medicine, social science, etc. And they are very powerful in summarizing the data, revealing patterns, and communicating insights with visual perceptions. But have you ever tried to understand a graph without seeing it? So now I want to invite all of you to close your eyes and try to listen to an audio.
This horizontal bar graph is titled Percentage of Respondents' Resources Reviewed. The x-axis is labeled Percentage of Respondents ranging from 1% to 100%. 4 resource review types are listed on the y-axis. They are written notes from session, video recordings, audio recordings, and other. This chart indicates that 90% of respondents used written notes from sessions, followed by 65% of respondents using video recordings, and 58% respondents using audio recordings. Only 10% respondents used other types.
And now you can open up your eyes. And this is a graph the audio is describing. And I'm not sure if that doesn't match with what you are hearing in your mental graph. And you probably it's very hard. But what you have heard is a paragraph of alternative text that is describing the graphs. And we all know that the graphs, they are translating the visual content into text so that screen reader users can depend on those texts to understand the graph. However, you might have noticed that alternative texts, they are different from captions. The captions, they are usually the complement the chart, and they either focus on giving extra information or only providing or mentioning the most prominent feature of the chart. However, for alternative text, they need to be the substitution of visual content, which means it bridges the gap between the graph and the screen readers so that screen reader users can rely on those alternative texts to build a mental graph and get access to the graph itself. And that's why, based on our research, the alternative text for the graph should include 2 types of elements. The first one is the basic visual elements, including the types of charts, the title, access labels, also legend. And the second part is you can talking about the prominent visual elements. For example, some statistics such as the maximum mean values, or what is trending in the line, or maybe some comparison between different categories, etc. And this example of the chart that we have listened before, for example, you can start by stating this horizontal bar graph, and you mention the title, and you can say the axis labels, what is on the axis labels. And on another level, you can mention what is the highest value for the bar and what's the lowest value for the other bars. And so after knowing what is alternative text for the graph, I want to show you a screen recording from Apple VoiceOver.
On average, these participants are following 236 people and they have 674 followers. Figure 4.1. Demographics of participants' age and gender. Figure 4.2. Education level distribution of participants.
So, as you have heard, the Apple VoiceOver is only reading out the captions, but there's no any interpretation of the graph. So, as screen reader users, they don't know what's going on in the graph unless there are some human support that either they interpret the graph for them or they do some modification in the PDF to make it accessible. But another point is we all know that all of this assistance requires time and knowledge effort. So back to the PAVE 2, in our research, we want to minimize the effort that human resources invested in both of time and knowledge effort. So ideally, we want to have a model or using AI model that can automatically generate alternative text so that we target for improving accuracy and efficiency at the same time. And in our solution in PAVE 2, we already implemented an AI-generated model that will automatically generating the alternative text at the starting point. So as a user, if they have done correctly in the previously 5 steps, which means they have tagging the figure as a figure, and when it's approaching to the step 6, and click the button of recognizing chart, a paragraph of automatically generated alternative text will appear on the white box below, where readers can rate, check, and correcting the wrong information until they are satisfied with it. And currently, we only focus on the single and numerical data-enabled graphs. However, there are many different interesting directions that have not been answered in research, and I thought it might be good to list 3 of them here. So the first one is a complex graph, which means there are many graphs that contains multiple subcharts. They might have intercorrelations, such as comparison, or they are zooming to each other, or they're in parallel relationships to display some information. And the question remaining is we still don't know how to describe those. And the alternative text model that we introduced at the beginning, they probably doesn't work for those complex charts. And similarly, the second point is that we found there are around 16% of charts or graphs in scientifics are flowcharts or block diagram. And they can be displayed in many different ways, in very complicated format. Similarly, we still don't know how to describe them efficiently to communicate the information. And lastly, which is also the challenge that we're facing right now, is we found describing graph is a two-way communication. So instead of focus on the alternative graph, the graph itself is very challenging, which means there are many graphs that are in poor quality and they are not self-contained. So if you're just looking at the graph itself, we don't know what it's talking about. And at that point, it might be interesting in the future if we can link those graphs to the main text or the main body text where there are more background information provided, which could be helpful to making those graphs accessible and much more helpful.